In 1989, Susie Creek in northeastern Nevada was barely a creek at all. It was a thin ribbon of water cutting through bare gravel, no willows, no sedge, no shade, just sun-baked dirt stretching to the horizon under sky that almost never delivered rain. Nevada receives less than 10 inches of rainfall per year, making it the driest state in the continental United States. Susie Creek looked the part. Not a river, not even a stream in any meaningful sense. A scar. Then 5 beavers walked in. Not airlifted by a federal agency, not part of a restoration program with a budget and a press release. They arrived on their own, drawn by changes so incremental that the ranchers who worked this land for generations almost didn't notice them. What those 5 animals did next, using nothing but mud, willow branches, and roughly 30 pounds of biological instinct each, would eventually be studied by the USDA Forest Service, the Bureau of Land Management, and peer-reviewed researchers publishing in journals like PLOS One. It would force a complete reversal in official U.S. fish and wildlife policy. And it would produce photographs so stark in their contrast, the same creek, the same month, 26 years apart, that government scientists initially struggled to confirm they were looking at the same location. This is the story of how the most systematically eliminated animal in American history turned out to be the continent's most sophisticated water engineer, and why the people who spent decades trying to destroy it are now the ones fighting hardest to bring it back. But to understand what happened at Susie Creek, you first need to understand what we erased. Before European contact, an estimated 60 to 400 million beavers occupied North America. That range is not imprecision. It reflects the genuine difficulty of modeling a population so vast it functioned as continental infrastructure. Their dams and ponds created more than 300,000 square miles of wetland, roughly equivalent to 1/10 of the entire land mass of the lower 48 states. A slow, interconnected network of water that recharged aquifers, buffered floods, and sustained entire ecosystems across every major watershed on the continent. Then came the fur trade. Beginning in the early 1600s, beaver felt became the dominant raw material for European hat manufacturing, and the animal's fate was decided by fashion. The Hudson's Bay Company alone shipped nearly 3 million pelts to England between 1853 and 1877. By 1900, the continental beaver population had collapsed to an estimated 100,000 animals, from hundreds of millions to 100,000 in 3 centuries. The consequences didn't announce themselves. They arrived slowly, invisibly, across generations. Without dams to detain water, streams cut deeper into the earth, floodplains dried, water tables dropped below the reach of plant roots. Wetlands that had stored billions of gallons simply ceased to exist. In the arid West, where every drop of retained water was the difference between a functioning ecosystem and bare gravel, the damage was total. What most Americans now accept as a natural western creek, a thin line of water between bare, eroded banks, is not natural at all. It is the landscape after beaver removal at continental scale. In Elko County, Nevada, where Susie Creek and Maggie Creek wind through 200,000 acres of ranch land, that erasure had been complete for nearly a century. In 1990, a young rancher named John Griggs took a job at Maggie Creek Ranch. One of his first assignments was to drive a load of dynamite back from Battle Mountain. His instructions were straightforward: blow up a beaver dam. It was standard practice. It was, as far as anyone in the county was concerned, the only rational response to an animal that flooded irrigation ditches and undermined the engineered order of Western water management. Griggs loaded the dynamite. He drove the truck back toward the creek. And then something happened that would take him 30 years to fully understand. He never used the dynamite. Not because someone stopped him, not because he had a change of heart born from environmental conviction, because when he got to the dam and stood there looking at what the beaver had built, the water backed up behind it, the willows beginning to push through the bank, the ground wet in a place that had no business being wet, something made him pause long enough to call Carol Evans. Evans was a fisheries biologist with the Bureau of Land Management, stationed in Elko County and already years into watching the region's streams collapse. She had the kind of quiet, methodical credibility that comes not from advocacy, but from documentation, from writing down what she observed, year after year, in a landscape that almost no one was paying attention to. When Evans drove out to Maggie Creek and saw what Griggs was about to destroy, she asked him to wait. To try something different first, to give the creek a season of rest, pull the cattle back from the riparian zone, stop trampling the bank vegetation, and simply observe. Griggs agreed. The dynamite went back in the truck. What happened next would take both of them years to fully explain, and it would eventually produce a body of documented evidence so contrary to a century of conventional land management that the institutions responsible for that management would have to reverse themselves publicly. But here is what you need to understand before we get there. The resistance Evans and Griggs faced was not ignorance. It was institutional memory. Every rancher in Elko County had been taught the same lesson by their fathers, who had been taught it by theirs. Beavers flood ditches. Beavers undermine banks. Beavers are the enemy of ordered water. That consensus wasn't irrational given what those men could see. What they couldn't see, what no one in the county had the historical frame to see, was that the landscape they were managing as normal was already a catastrophe. The bare banks, the incised channels, the streams that ran hard in spring and vanished by August. None of that was natural. All of it was the long, slow consequence of removing the animal that had built the West's water system in the first place. Think about that. The ranchers weren't fighting beavers. They were fighting the last survivors of a species whose absence had already broken everything around them. And when Evans asked Griggs to wait, to simply stop and watch, neither of them could have predicted what the creek would do next. What happened next is where the story stops being counterintuitive and starts being extraordinary. In the first season, after the cattle were pulled back from the creek bank, willow saplings began to emerge from the bare gravel. Not planted, not seeded by a restoration crew, they came up on their own. From root systems that had been suppressed for decades under the pressure of hooves and overgrazing root systems that had simply been waiting for the weight to lift. The beavers, responding to the returning vegetation with the same instinct that had driven their ancestors across the continent for millions of years, began to build. First one dam, then another. Each dam raised the local water table slightly. Raised water tables allowed more willows to grow. More willows drew more beavers. The cycle, once broken, was reassembling itself, not because of human engineering, but because the conditions for its existence had been restored by the single act of standing aside. By the mid-1990s, Evans was documenting something that had no precedent in the land management literature for this region. The stream channel, which had been cutting downward for decades, had begun to aggrade, to fill back in, to rise, to reconnect with its floodplain. Water that had previously raced off the landscape in spring and vanished by July was being detained, slowed, spread laterally into the soil. The aquifer beneath Maggie Creek Ranch was recharging. Not from increased rainfall, Nevada's precipitation hadn't changed. From the structural work of an animal that weighs 30 pounds. Evans later documented that the key intervention had not been the beavers themselves, but the removal of the pressure that had prevented the ecosystem from supporting them. The beavers were not the solution introduced from outside. They were the solution the landscape had been generating on its own the moment humans created the conditions for it. If this is reshaping what you thought you knew, hit subscribe. This channel goes deep on stories like this, the ones that challenge the official narrative with actual, documented evidence. Now back to Maggie Creek, because what the data showed next transformed not just this ranch, but the entire framework for how the American West thinks about water, and the numbers are almost impossible to believe until you see them mapped. The data didn't trickle in, it compounded. By 2006, when Evans and her BLM colleagues conducted a formal survey of Maggie Creek Ranch, they counted 107 beaver dams distributed across the watershed, not clustered in one productive stretch, spread across the landscape in a branching, interlocking network that was operating collectively as a single water storage system of staggering scale. Each dam was individually modest: mud, willow stakes, accumulated debris. Together, they were functioning as infrastructure, that no state agency had budgeted for, planned, or built. 4 years later, the count reached 271. Let that land for a second. 271 dams, constructed without permits, without contractors, without a single dollar of public expenditure, by a population of animals that had arrived uninvited and been nearly destroyed for the offense. The hydrological consequence of 271 dams operating in sequence is not merely additive, it is exponential. Each upstream dam raises the water table for every structure below it. The ponds behind them don't just store surface water, they force water downward, laterally, into the surrounding soil, creating what hydrologists describe as a subsurface sponge capable of retaining moisture long after the last rain has fallen and the last snowmelt has run. In a state that receives less than 10 inches of precipitation per year, this distinction is the difference between a creek that flows in August and one that doesn't. Then came the ultimate test. Between 2012 and 2015, the American West entered one of the most severe droughts in recorded history. Across Nevada, ranchers were trucking water to keep cattle alive. Streams that had never run dry within living memory stopped flowing. The USDA declared drought emergencies across dozens of counties. At Maggie Creek Ranch, Susie Creek remained green, not struggling, not reduced to a trickle. Green with deep pools, standing water, and nesting waterfowl, while the surrounding landscape turned the color of concrete. This was no longer anecdotal. This was a controlled observation playing out at landscape scale, with drought as the variable and beaver hydrology as the only meaningful difference between one ranch and its neighbors. The peer-reviewed literature was beginning to catch up. A landmark study published in PLOS 1 examined how beaver pond complexes along western streams create localized cold water refuges, pockets of deep, slow, thermally stable water that remain inhabitable for fish species like Chinook salmon and steelhead trout, even when surrounding stream temperatures rise to lethal levels during summer droughts. The mechanism is simple and the implications are not. Beaver ponds are cold because they are deep, and they are deep because beavers engineer them to be. In a warming west, where stream temperatures are climbing toward thresholds that cold water fish cannot survive, the beaver is not merely a water storage device. It is a climate buffer, a biological thermostat. Built and maintained at no cost, generating ecological services that no human engineering project has yet replicated at comparable scale. If you made it this far, you already know this channel doesn't look away from the stories that matter. Subscribe and share this with someone who needs to see it. Now back to the research, because the Bridge Creek study, conducted independently in Oregon, took everything documented at Maggie Creek and pushed it even further. And what those scientists found forced a question that is now being debated at the highest levels of federal water management. If the beaver can do all of this for free, what exactly have we been spending the money for? The Bridge Creek study didn't just confirm what Evans had documented in Nevada, it quantified it. Conducted by researchers at Utah State University along a tributary of the John Day River in north-central Oregon, the Bridge Creek study introduced a controlled variable that Maggie Creek had not. Where beavers were absent or insufficient in number to colonize on their own, scientists installed beaver dam analogs, hand-built structures of wooden posts and woven willow branches designed to mimic the hydraulic function of a beaver dam without requiring the animal's presence. They are, in the most literal sense, a human attempt to replicate in engineered form what the beaver does by instinct. The results were peer-reviewed and unambiguous. Within 2 years of BDA installation, the monitored reaches of Bridge Creek showed measurable increases in water table elevation, channel width, floodplain connectivity, and critically, steelhead trout population density. Steelhead, an endangered species, recovering. Because of sticks and posts arranged in a pattern a beaver would recognize. The cost comparison is where urgency enters the picture. Traditional stream restoration in the American West, the kind involving excavators, engineered rock structures, riprap, and contracted labor, runs between $50,000 and $500,000 per stream mile, depending on complexity and access. The BDA installations at Bridge Creek cost approximately $500 per structure. A single mile of stream requiring 10 to 15 structures, which is the documented density producing measurable ecological recovery, could be treated for between $5,000 and $7,000. Not $50,000, not $500,000, $7,000, for equivalent or superior ecological outcomes, according to the published data. This is not a fringe calculation from an advocacy group. It is the documented finding of researchers at a land-grant university, published in peer-reviewed journals, and now being actively incorporated into restoration planning by the U.S. Fish and Wildlife Service, the Bureau of Land Management, and the Natural Resources Conservation Service simultaneously. 3 federal agencies, no shared ideology. All arriving at the same conclusion. The cheapest effective tool for Western water restoration is a structure that a 30-pound rodent invented roughly 5 million years ago. Drop your thoughts in the comments. We read every single one. If this video showed you something you've never heard before, hit that like button and subscribe. Now back to Susie Creek, because the final proof of everything documented in these studies is not a graph or a federal agency memo. It is 2 photographs, same location, same month, 26 years apart, and once you see them side by side, the argument is over. In September 1989, Susie Creek was scarred, bare gravel, no shade, a thin line of dying water in the driest state in America. In September 2015, at the peak of the worst drought in recorded Nevada history, the same location was a lush corridor of deep pools, standing willows, and nesting waterfowl. Nothing changed in the rainfall. Nothing changed in the geology. Nothing changed in the climate of Elko County between those 2 photographs. What changed was the presence of an animal that humans had spent 3 centuries systematically erasing from the landscape, and the decision of one rancher on one afternoon in 1990 to put the dynamite back in the truck. Here is what this evidence, taken together, actually means. 60 to 400 million beavers, 300,000 square miles of wetland, a continental water system built over millions of years, dismantled in 3 centuries for hat felt, the water tables that dropped, the floodplains that dried, the rivers that incised, the droughts that deepened, the fires that burned hotter and wider across a west that no longer had a sponge beneath it, 107 dams by 2006, 271 by 2010. Susie Creek, green in a record drought, while neighboring ranches trucked water to keep cattle alive. Steelhead recovered in Oregon because of posts and willow branches arranged in a pattern a beaver would recognize at a cost of $7,000 a mile. 3 federal agencies, independently, arriving at the same conclusion. The shape of all of this is not subtle. The American West's water crisis is not primarily a story about climate. It is a story about what we removed. The droughts we now call historic are being measured against a baseline that was already catastrophically depleted, a landscape that had been quietly engineered for water retention for millions of years, then methodically unmade in 3 centuries, then called natural. What we call drought may be, in significant measure, the compounding consequence of an ecological amputation so large and so gradual that we mistake the wound for the original condition. The question is no longer whether beavers can restore western watersheds. 30 years of documented evidence from Maggie Creek Ranch alone has settled that. The question is whether an institution, a government, a land management agency, a culture, can move fast enough to reverse a 3-century mistake before the watersheds. It depends on pass a threshold from which no amount of engineering, biological or human, can recover them. If this video changed how you see the West's water crisis, turn on notifications, because what we're covering next goes deeper into the science of what was lost and what is still possible. Share this with someone who needs to see it, and drop your thoughts in the comments. The conversation this evidence deserves has barely begun. In 1989, Susie Creek was a scar in the desert, and we called it normal.